All right, as I said earlier, before you took the quiz, I'm not going to be here tomorrow, so I want you to take the guided notes on multiplying polynomials on section 7.7, and then tomorrow during class, you'll basically be working on what would be the homework. So get these notes down, bring the guided notes with you to class, and then you will do homework with using your notes as a guide. All right, on multiplying polynomials. Okay, as the first thing says there, when multiplying polynomial powers with the same base, keep the base and add the exponents. That is the same as we've done before in section 7.3 with multiplying. So x squared times x cubed equals x to the fifth. Okay, now we're going to take a look at a couple cases here. The first one is what we call a monomial times a monomial, a single term. You've actually done this before. We're just going to review it for this part. When you have this, you have two monomials. You multiply the coefficients together, the 6 and the 3, and they multiply together to give you 18. You add the exponents together, so it's going to be y cubed times y to the fifth. Whoops. That will be y to the 8th. Now there's nothing else you can do with this one. You're done. So 6y cubed times 3y to the 5th is 18y to the 8th. Now on the other one, 3n squared times 9m squared n. Multiply coefficients. 3 times 9 is 27. M times m squared, you add exponents. M to the third power, and n squared times n is n to the third power. That's all you need to do for that one. So multiply coefficients, which are the numbers in front, and add exponents. Okay, so those are kind of two rules for when we're multiplying. All right, that is a monomial times a monomial. Now, to multiply a polynomial by a monomial, the monomial will usually be in front. The polynomial will be in parentheses. You use the distributive property. Just like we have before, this is really no different except we may have a variable with the monomial. So in this case here, you distribute the 4 and you multiply it by all three terms in the parentheses. So that is going to be 12 x squared plus 4 times 4, which is 16x, and then 4 times negative 8, which is minus 32. Now, if there are any like terms, we add them together. We don't have any. That would be your final answer. Put it in standard form, the x squared first, the x, and the constant last. Okay, now this one has variables with the monomial. There's two terms in parentheses, so it's a monomial times a binomial. Take 6pq times 2p. Then take 6pq times negative q. Well, 6pq times 2p is 12p squared q. Okay, you would add, this is a p the first, add those together, you still need the q. Minus 6pq times negative q would be 6pq squared. These are not like terms. That would be your final answer. All right, that was a binomial or a monomial times a polynomial. This is a special case. We call it a binomial times a binomial. You have two terms in this one here, two terms in this one here. Now, a lot of times when people look at it, they want to say the answer is x squared plus 6. That is wrong. Okay, because here's how you have to do this problem. You have to take the first x and it has to multiply by both parts of the second term, the second binomial. X times x is x squared. X times 2 is plus 2x. Then you have to take the next term of the first one, which is 3, and multiply it by both terms of the second one. 3 times x is 3x. 3 times 2 is plus 6. Those two middle terms can be added together. 2x plus 3x is 5x plus 6. That is the final answer for that one. So this is going to be a little bit different. You just can't multiply the x times x and 3 times 2 and say you're done. That does not work. Okay, final answer, x squared plus 5x plus 6. Now this also has a name to complete this. It is called the FOIL method. Okay. F stands for first. O stands for outer. I stands for inner. And L stands for last. So what I just did was actually the FOIL method. When you take x times x, those are your first two terms. That's x squared. When you take x times 2, they're the outside terms. That's 2x. When you take 3 times x, that's 3x. And 3 times 2 is 6. I'm going to use the FOIL method to solve a binomial times a binomial. Okay, now I think you should be on the back of your paper. Flip that over. Alright, let's use the FOIL method to multiply a binomial times a binomial. So first is x times x, which is going to be x squared. The outer terms, I usually like to do this underneath, it would be the 2 on the far edge would be x times 2. Now treat that negative and make it minus 2x. Okay, the inner terms. You start at the 4 and 4 times x. And then the 4 and the 2 are what we call the last terms. 4 times negative 2 is minus 8. Now when we do this, you always have to check to see if you have any like terms. The two middle terms are like terms. We add those together, and negative 2x plus 4x is plus 2x. And then we have, as our final answer, x squared plus 2x minus 8. Okay? So, x times x is first. The x times the negative 2 is the inner. Or excuse me, those are the outer. 4 times x is your inner, and then the 4 times negative 2 is the last. So we get FOIL. First, outer, inner, last. Okay, let's take a look at the second one. Now that first one just had an x, it did not have a number in front of it. Now we have 2y times 3y, or 2y minus 5 times 3y plus 2. Okay, take your 2y. The first means you take 2y times 3y. Multiply coefficients, add exponents. That's going to be 6y squared. Take the 2y times positive 2. That's your outer. That is positive 4y. Take your negative 5 times the 3y. That is your inner. It's minus 15y. And take your negative 5 times positive 2. Those are the last ones. That's minus 10. The two middle terms are like terms. We can add those together. We get 6y squared minus 11y minus 10. That is our final answer. All right, I'm going to pause here for a second because I'm going to have to start a second video. So hold on 1 second and then open up the second one here when you're ready.